All right, so let's go ahead and wrap up our discussion here. This is why do I keep missing that? Part 4 of the lecture on conventional energy. Again, remember we talked about coal, oil, natural gas, and then now we've been talking about nuclear fuel or nuclear energy. Oil being the dominant one right now, gas starting to become more and more popular because of the environmental benefits. But all those energy sources, every energy source has pros and it has cons. We want to weigh out both sides and make the best decision possible. So the last lecture we were talking about, we left off with nuclear energy, nuclear reactor, and uranium. Uranium is one of the main elements used for nuclear energy. So we process it into those pellets. Pellets get packed into rods. Rods get bundled together to make a fuel assembly. A bunch of those shoved together, create a reactor core. Now, once you have the reactor core set up, then we use nuclear fission to release the energy. So uranium gets hit by a neutron. So remember our chemistry again: protons, neutrons, electrons. We hit uranium with a neutron, and let's follow that path up here. Let me get red for this. Here's our neutron. Hit the uranium. Uranium becomes unstable. And as it becomes unstable, it starts to break down. Uranium releases neutrons, which then go and hit other uranium. And then uranium gets converted to tin over here. Oh, there's another neutron. Oh, some of the uranium also gets converted or changed into molybdenum. So all these things are coming out of this uranium when you make it unstable. Big thing that comes out: heat, heat, lots of heat, heat, more heat. So each of the neutrons coming out trigger additional breakdowns of uranium. But the heat coming out is what drives a turbine to generate electricity. So it's like, okay, that triggers what we call the chain reaction, a nuclear chain reaction, when this original neutron goes in and boom, 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 and it creates a domino effect here. So heat's generated, turbine spins, electricity is produced. Awesome, great. The concern is nuclear meltdown. The nuclear reaction produces a massive amount of heat. So we want to keep that in mind. Circle that. Big star on that. Lots of heat. All energy production produces heat. It's the laws of thermodynamics. So to prevent meltdown, to maintain a safe environment, you need a lot of water to keep your reactor system cool. Now there's a variety of different reactor systems. We're not going to get into those during this course. That's not what this is about. Our concern is if a reactor system is not kept at an optimal temperature, it goes into meltdown. That's a failure of the reactor system. That is a very, very big, big problem when your reactor core is not kept at the optimal temperature and your system starts going into meltdown. 2011, Japan got hit by a major earthquake that triggered a tsunami. That tsunami came in and disrupted the Fukushima nuclear power station, and it triggered a meltdown. The wave, as it came in, it changed disrupted the land formation and basically became unstable. And then now your nuclear reactor isn't on a stable platform anymore because of an earthquake, the tsunami issue, and the core cracked, water leaks out, cooling system's no longer effective, core starts melting down. They evacuated as broad of a radius as possible, and then have to let it just melt down. You can't go in and put out a nuclear reactor. That is why people are so afraid of nuclear power, or one of the primary reasons is the safety side of it. It's okay, it basically melted down safety. Because of this reaction, eventually it goes out. All right, all the uranium is used up. Your power plant goes offline, collapses, implodes, whatever. But you have all this nuclear material there that has to get cleaned up, that has to get contained. Well, this meltdown happened during a tsunami. It's not going to get contained. So this diagram, the picture you're looking at here, this is the path of the nuclear fallout from that meltdown. The nuclear fallout got carried on wind and ocean currents away from the coast of Japan. So everybody who was downwind and downstream got exposed to nuclear fallout. Some of it was fairly immediate, within days to weeks. Some of it was months later that this nuclear fallout eventually reached different regions. So the concern about nuclear is it's the radioactive material used. So when you have a failure, it's a massive failure. It's a significant failure, and that can lead to some very, very big safety issues. So ultimately, the challenge here is to try to figure out how do we decrease our reliance on these traditional energy sources. Let me do this. Let me get in here so I can fill this out for us. Okay. Future energy goals is what we're looking at here. Big one, decrease our use of traditional sources. How can we how can we avoid relying so much on fossil fuels? They are going to run out. They're not renewable. They're environmentally damaging big time. There's all the negatives. But what else do we have? That's what people need to continue to explore. We'll get into this in the next lecture about alternative energy sources, renewable energies. Can we drive more use towards those areas? Can we move away from the traditional sources, find environmentally friendly options that produce equal or more output of energy? And I guess this really should have been the first one. Can we get people to simply decrease energy consumption? Basically, we need more energy efficiency. Whether we're still using coal, oil, firewood, natural gas, nuclear power, if we can decrease our energy consumption, that's going to make a huge difference. Environmentally, financially, all those things need to be we need to focus on, or to be recognized, and try to identify what is the optimal long-term big picture solution to this, because we have a couple billion people heading towards this planet in the next 20 to 30 years through population growth. We need energy, just like we need food, just like we need clean air, we need clean water, we need all these resources. How are we going to do it for all these new people that are going to be born to this planet in the very near future? So again, we will talk more about alternative energy sources and those things in our next several chapters, and take this unit as a whole and look at it as dealing with the energy issue in our society and on our planet.